Who wouldn't want to do
Is
that?
it not?
That'd be awesome. I'm going to get married end of next year, so I'd love to fly into my own wedding type thing.
Wow,
Nice.
cool.
It's a dream. But
Yeah.
it's not going to happen. I'll have to hire Captain
fly
out.
option.
That's better. Right. To accommodate newcomers, you know, when we do these ground schools, I do them once a month at the moment, trying to make sure that somebody that hasn't maybe studied any of it can follow along, but somebody that has done studying, like Tony's studying for his commercials, so he wants to try and get something out of it. And there's no way we can touch every single part of aircraft general knowledge tonight. It's just not possible in that period of time.
Yeah.
So we'll have a bit of a generalization, and maybe, you know, as we go along, we'll find somebody, everybody's like, oh, can you tell me more about that? And we'll sort of concentrate on certain areas.
Yeah.
So when we talk about the exams, you guys online can't see, I'm looking at Adam because he's quite new to it. We've got 9 multiple choice ground exams got to go through for the PPL. And the good news is the answer's already in front of you. So you got a kind of a sort of a 1 in 25, 25% chance of guessing it right, haven't you? But the problem is if you sort of read the question and kind of read the answers, your chances are you'll get led astray on it because you'll come up with you'll convince yourself of the wrong answer.
Yeah.
So you're almost better off covering the answers up, read the question a couple of times, make sure you really know what they're asking before you even think about looking at the answers. But we always say the same thing, talking to some experienced guys in the back room, they're doing an open exam at the moment, that yes, of course, we need you to pass the exam, 75% pass mark, but what we really want you is to have that depth of knowledge. You know, I don't want somebody at 100% that's got no idea why they got the right answer. They just know that was the right answer. We want to be a bit more in depth with it, don't we? So that's really key to it, that depth of knowledge. So that's what we try and focus on.
How many questions are there usually on an exam?
Each exam is between 12 and 16. I can't think of anything that has more than 16. So it's just 12 or 16 questions. The exam can be as short as, is it 20 minutes for comms? I think it's 20 minutes for comms or 55 minutes. It might be for operational procedures. I think, just off the top of my head. But it's somewhere between there. So say less than an hour, but usually more than half hour. So it doesn't sound too bad. You think, gosh, there's only 12 questions. I've got easy 2 minutes per question, haven't I? Easily, but yeah, it disappears fast. Yeah, it sure does. Yeah. Anyway, so aircraft general knowledge. What's that all about? Who wants to take a plunge and tell me? Because I'm not sitting here doing the whole lot.
I'm assuming it's to do with airframe, just to do with aircraft instruments, controls. I'm assuming.
Yeah, absolutely. Sophie, can you hear Lester okay? Oh, okay. You can hear me all right, obviously, can't you?
Yeah, but only when you speak towards the microphone. Actually, you know, when you are on the side, we can't hear you. Or
no problem. I'll do that classic. I'll repeat some of the things.
Well, you know what? I was actually thinking I need to buy him a microphone, and you know, the one that you can put like a basically.
Can I have it on an extender, please? So I don't forget I can just retract it out. All right. So
no, but they've got some kind of things here that you can put in the middle of everybody. Well,
don't worry. Yeah, so things like it might be to do with airframes, instrumentation. Yeah, absolutely. Who wants? What else?
All mechanical, is it?
It's basically more or less mechanical. Yep, it's to do with the aircraft, isn't it? I noticed it didn't necessarily even say helicopter, but we talked about helicopters. Didn't say which one though, did it?
No.
Didn't say whether it's got a piston engine or a turbine, or eventually, I don't know how far down it's going to be, but electric. So it's going to come at some point in time, isn't it? Or is it going to be hydrogen? Anyway, we'll go down that. We'll have that chat afterwards. So, and different rotor designs, etc. How many rotor blades, whether it's a fenestrum, tail rotor. Yeah, it's just general, isn't it? So we can start to kind of almost break this down into probably things like engines, gearboxes, the airframe, the electrics, rotor designs, tail rotor, skids, or sorry, I should say some sort of undercarriage, some sort of landing gear. And that kind of more or less, there's a bit more to it than that, but that more or less summarizes it, breaks it down to those individual components as well, those areas. Good. So previously, but wind the clock back just not that many years, the exam was all based on piston engine helicopters. And a lot of it still is. A lot of the questions are geared up towards piston engine, but then they like to chuck in a load of the turbine questions because you could easily be doing your PPL in a turbine, and we do have people that do that. So that's why you do need to learn about turbines, because otherwise, once you've got your license to fly the Cadbury, for instance, and you think, oh, I'd like to have a go in the Jet Ranger now and get my rating in that. It would, you cover all of this in the type rating, but it's seen that you ought to have some knowledge prior to that point as well anyway, i.e. the study and the exam. Anyway, so there's turbine questions as well.
Yeah.
So you can't just say, oh, I don't need to know about that. I'm learning in a piston engine. It's no, you need to know about that as well.
I think one of the questions I had in my exam was about notards.
That's right, yeah.
I knew nothing about notards.
Yeah, so don't know if you can hear Ross is just saying he had a question on notars. Yep, all that's the Coanda effect that potentially can crop up in the exams as well. So yeah, when it comes to learning, you've got to really try and learn everything. And then if you go down like poor James and Tony, etc., did in the commercial route, yeah, need to learn a lot about aeroplanes and all sorts of things you're probably never going to need to use or know about. But you know, it's very important if you're going to fly your helicopter from the UK to America in one hit, isn't it? At 30-something thousand feet.
Hey, good luck with that. I'm gonna part of the journey, please.
Yeah. Anyway, I get it. It's just to show you've studied and that knowledge. So anyway, reeling back in aircraft general knowledge. So what should we talk about? Let's just talk about some engines. So let's talk about a piston engine. What can you tell me
about a piston engine?
Yeah, it doesn't have to be you, Adam. By the way, I do look at you, but I'm looking at the others and online.
That's probably laughing my answer. No, so there's 6-cylinder like R22 technically. Am I right there?
That's 4, but you
Four,
it's okay. Yeah, there's cylinders. Good.
4-cylinder. I thought it was 6.
What's a cylinder?
What's cylinder?
Yeah.
Piston goes through.
Yeah.
CC of the engine is all the pistons
And
combined.
Good. Yeah. Keep
7
talking.
meters of the
I'll
piston.
disappear for a second and come back. Keep talking. And now, please.
You gotta have how many valves would something have? So that would be to do with what's on top of the cylinder to allow fuel and air.
Yeah, so
Mixture in. So if you have,
it's like how many spark plugs does an R22? Yeah.
so I presume it would have backups. So I'm presuming it would have 8 then.
There is
Am I correct?
a cylinder about the
That's
size.
cool.
The sort of size you find on a moped. When you think of a little 50cc moped cylinder, it's about that about that diameter and about that deep. It is not like this. I mean, this is big.
Huge, isn't it?
This is 1.5, basically more or less 1.5 liters. This is from an R22.
Oh, it is. Okay.
Yeah, please. Yep, cool.
Okay.
What, 6-litre engine?
But virtually 6 litre. Yeah, virtually.
Yeah.
Being American, it's only cubic inches.
Right.
So 360 cubic inch for this one. There is a slightly smaller engine, 320 cubic inch. This is a 360. So yeah, there it is. Oh, big old lump. Very, very basic. It's only got, if you know anything, it's only got 2 valves, just one inlet, one exhaust.
Yeah.
But it's quite heavy as well because it's cast. 2 things sticking out. Oh, hang on. 2 things sticking out here.
Spark plugs.
Yeah, so 2 plugs per cylinder. We'll come back to that. But anyway, there's a cylinder.
So that's
So
a backup for the spark plugs, I presume. Is it redundancy?
Yes, well, a couple of things. So we'll come back to that in a second,
Yeah.
but it's a really good question. So I don't know if you can hear Adam sort of asking why 2 spark plugs, but like I said, we'll come back to that in just one moment. So hold that thought. So what's the kind of the basic principle of a piston engine?
The cycles to be able to bang the fuel and the air and make the rotor turns. Spin.
Yeah. Anything
We have a
else?
cycle, so it'd be a crankshaft. As one goes up, it would spin the crank, which would it's a loop, isn't it? A loop system.
Kind of
essentially.
thing. Yeah, yeah,
Yeah.
yeah. That's it. Yeah. So I think we understand I've got a piston as well down there, but it won't go back into piston rings on it. But there's a piston that's going to go backwards and forwards in there. So it's a bit like I sometimes, for people who've got no mechanical knowledge, I start off with a hypodermic syringe because most people have seen one of those. And kind of, if you move the plunger one way, you can suck something in. If you push it the other way, it might push something out. And it's a very crude cylinder, but it'll do to begin with. You can kind of build upon that. Otherwise, you start just rattling off cylinders, pistons, common rods, blah, blah, blah. People got no idea what you're talking about, unless, of course, you show them pictures. And even then, they still can't really get their head around it at first. So you might just sort of say it's almost like a plunger in there, a piston. So the basic principle is you're probably going to have to use that to draw, like a syringe, draw some probably air and fuel into there. And again, that leads on to, we have to talk about how the air and fuel is going to get mixed and go in there. But that's usually by a carburetor. Anyway, going to draw air and fuel because you need both those things, don't you, to make it all work? Because you ideally want to cause an explosion, and then you're going to harness that power, aren't you? That's really what it boils down to.
Yeah.
So suck in that air and fuel. It's probably going to have some sort of valve system to let that in. So we might as well call that an inlet valve. Aha. Get that open. You can suck it in, but then we better close it off because you actually want to squash all that. You want to squeeze it all together and compress it. Because why do you want to compress it though?
Because you want the power and the bang of the.
Yeah, but why not just set light to the air and fuel as it is?
You wouldn't get the same power coming from it.
That's correct. Yeah, yes. It wouldn't, you just wouldn't get the same power from it. You compress it and set light to it, ignite it. You get a lot more energy released from it. Because what we're trying to do is to get it to push that piston back down. So we've sucked in some air and fuel, shut off the valves, squashed it all. Then we're going to set light to it. So we're going to get that explosion, that bang, which is then going to try and push that plunger back out again. And it's that you're trying to harness, isn't it? But of course, you've now got inside that cylinder a whole load of burnt gas and fuel. You've got to get rid of that. You need to exit it or exhaust it out of another valve, an exhaust valve. So the plunger will go back in, squidging it all, forcing it out that exhaust valve, and then repeat the cycle. So we've got suck, squeeze, bang, and blow it out again. And then it's going to repeat the whole thing. So suck, squeeze, bang, blow, suck, squeeze, bang, blow. And that's 4 strokes, isn't it? 1, 2, 3, 4. So hence the 4-stroke engine. So if you've only got one cylinder, it's going to take quite a lot before you get back to that power stroke again. But if you've got 4 cylinders, that means each stroke can be a power stroke because one of the other cylinders will do it at a different time. And then if you've got 6 cylinders, that's good because you can have you can squeeze an extra 2 in there during all of that, 8 cylinders and blah, 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 can't you? And therefore, generally, the more cylinders, potentially the more powerful, certainly the smoother it will run. What's the only downside with adding more cylinders?
The weight.
Somebody said fuel, weight,
Reliability.
physical size. One might argue it's more reliable,
To have more.
potentially, to have more, potentially.
There's more points of
I
failure,
understand there's more points of failure,
surely.
but possibly that engine might not be doing as much work as you might think. It might be able to rev slower, for instance. Therefore, it's not actually turning around as much as some poor little, one cylinder revving its heart out, and a little 2-stroke, doing like 17,000 RPM or whatever. Whereas your big old V8 just lumbering along at a couple of thousand RPM, for instance. Anyway, yeah. So there's multiple reasons, isn't there? But also, you don't want to make each cylinder too big because you just can't set light to that stuff quick enough to get the decent power out of it. So there comes a point where the cylinders can just be too big for this sort of thing, for what we're trying to achieve. Okay, everybody happy with that so far? Good. So we won't go too heavily into. You're going to connect these pistons to a thing rotating round that's got sort of offset bits that kind of does this sort of motion like bicycle pedals. So we'll call that a crank or a crankshaft.
That does all the valves, isn't it? Timing of the valves.
Potentially, but that's got to be done by a camshaft.
Camshaft.
But we'll cover that another time. So I said about this fuel air mixture. So how are we going to control that? Because if that's what's going to produce the explosion, as it were, the fuel, how are we going to control that?
for the percentage of
Carburetor.
and that you put in
Yeah,
together.
the carburetor or injectors, isn't it? One or the other.
Yeah, carburetor, or just say fuel injected. Hello.
Good evening. Apologies. My name's Constantine.
Hey, Constantine, hello there. Come on.
I just landed actually.
Come and join us. Come sit down. There's a coffee machine. If you want a coffee, there's possibly a bit of pizza left. Yes, there's a few slices. If you want. Yeah, come on.
Paul. Are there still pizzas?
Yeah, there's still a little bit of pizza left, believe it or not. Yeah,
Can I have a slice?
I think everybody's being polite. Yeah, it might be a bit cold by the time it gets to you.
Never mind.
Crankshaft, yes, and so of course we're turning that reciprocal motion of these pistons going backwards and forwards, and it's horizontal in these engines, not vertical like a typical car engine. It's a flat like a
So good
Porsche.
reason for that.
What's that? The flat?
The fact this is horizontal, not vertical, or not V.
Yeah, we'll come back to that. It's a good question. Sorry, reciprocal motion. Oh yeah, carburetor. Sorry, I lost my train of thought. Carburetor. So
More
we can
about
use this thing called a carburetor to control the amount of. Do we control the air, or do we control the fuel, or do we control both with the carburetor?
Both. I think the carburetor has that.
Good. Yeah, inside the carburetor, there's a valve, a butterfly valve in there. Does that control the air or the fuel or both?
Both, isn't it?
But that,
No, the air.
That's the air. That's the air, but the carburetor.
there's another tube that
There's
goes
an
into-
injection.
So,
Well, not injection, it's wrong word.
Constantine, what's your mechanical knowledge like, sir? Not putting you on the spot. So, yeah, okay, it's all right. All right, so we're just just trying to provoke people to think about a question rather than me just sitting here.
I'm sure the air
Telling you
filter, there's an
things.
air filter that goes on the side of the carb.
Well, the air filter just filters the air. So I'm asking, does the butterfly valve that's in the carburetor control the flow of air, the flow of fuel, or both?
So air, yeah.
Flow of air.
Yeah.
So that's both.
So flow of air, stick your hand up. I'm not putting my hand up, by the way. So don't look at me.
The flap is air, yeah.
Flow of fuel, stick your hand up. Flow of air and fuel, stick your hand up. Okay, well, it's really just the flow of air. Yes.
Really?
Yes, because the flow of fuel is controlled by the venturi effect. Strictly speaking, you're not controlling the flow of fuel. That's measured out by the jets, etc. But as the air rushes through a carburetor, it passes through a narrowing, which causes a slight drop in pressure and temperature, which is not so good. And that drop in pressure compared to atmospheric pressure, which is almost what either how you view it, sucks the fuel in or pushes the fuel in. Doesn't really matter how you want to view it. The fuel manages to go through into that venturi, into the carburetor. So you're strictly speaking not controlling the fuel flow. What?
I guess you could argue that the faster the flow of air, the quicker it's going to
Absolutely, yes, of course it is.
It's a constant supply of fuel from a fixed jet.
Correct. You're not controlling the fuel flow, whereas fuel injected, you're potentially controlling to a degree the flow of fuel. In these old systems, that's not perfectly true, but it's a slightly better analogy. So when fuel injected in these engines, you're still controlling a flap with your throttle, but you are kind of controlling the fuel meter as well. Whereas in the carburetor, nope, it's left to its own devices to decide how much fuel will be sucked through that venturi. And thankfully, it's been very carefully designed and measured and metered that it will do the right amount. Remember, it's not being pushed by the pump; it's just being sucked in there.
Interesting.
So yeah, that's almost like a typical exam question. You know, does the carburetor control the flow of air, flow of fuel, both, neither, or some other random thing? You think, well, there's definitely usually one of the answers is completely nah, that's no good. But oh damn it, there's three that are actually half decent. Certainly two that 50-50 here. Yeah, and that was the idea. Is it's designed to really draw out your technical knowledge. If you're not careful, you think too deep into it. So you almost be off
So
going.
funny, I've taken car engines apart and put it back together, and I was second guessing the carburetor. So I actually don't know. I had no idea.
Yeah, so
That pulled that the fuel gets
That's right.
regulated by the
Why-
air. I had no idea.
you know, you say you might have worked on vehicles or engines for a long time. Do you need to know actually the venturi effect, how that works? Not particularly. You just need to know that there's bits in there that can easily get blocked up with debris that you'll probably have to blow out and make sure the filter's good, yeah, etc., etc. But we want to go just that step further and understand how that happens. So why would it therefore be important to understand something about this venturi effect inside the carburetor? I mean, you could just say it just works. It just does. But there might be a very good reason to understand how it works, which is.
Something with ice carving.
Could you say it a bit louder, so?
So is that about ice carving? Need to know,
Yes,
where you
carburetor
modify-
icing.
Yeah.
Because you hear us say Bernoulli's
Something
theorem
like
talks
that.
about, it's actually how really a wing works as well, but inside that narrowing as it rushes through there because it wants to speed up to get through, it's almost like it's gained an energy. Well, it can't just gain an energy from nowhere. Something's got to give, and it's the pressure / temperature that gives. Pressure drops. That's why it's got venturi, so the fuel flows, it sucks it into there, but the temperature drops. And it can drop by how much inside a carburetor?
A lot.
Yeah. How much is a lot?
You'll have to turn to us.
Yes, but potentially how much?
Can't remember, but I'm going to take a guess.
Come on, you
About
guys have been
40
studying, and
degrees.
Ross has gone for 40. Go on, James.
At least 100.
Hey!
20. I'll say 20.
20. We've got 20, 40. Any other offers on that?
Well, I'm going to go for getting down to zero, because if you're talking about icing, then it means you can get down to zero to get ice.
Exactly. But what's the temperature start at to begin with? It might have only been 1 degree. Well, it can easily drop up to 30 degrees in there. There's a few factors that will influence this, but I'm not going to say can't do 40, Ross, because it can possibly, maybe under exceptional circumstances, but either way around. So we now will understand, the Bernoulli's theorem that makes that fuel flow through that into that carburetor, unfortunately, as a nasty side effect of dropping the temperature significantly in certain circumstances.
I just remember that even on a
Yes.
hot British summer day, you can get.
That's right. So we virtually
It's
teach in the
quite
in the
convincing.
UK, you can pretty much get carb icing, even when it's really quite hot. There does come a point where it's just not possible because the temperature is just so great it can't drop sufficiently as it passes through the car. But we more or less say just always be on your guard. But it'd be true to say generally the colder, more damp it is, definitely, and more lower power settings and all these sorts of things. But so that's why we want to understand a bit about Bernoulli's theorem. And then it also, like I say, it'll lead on to how lift is generated when we talk about wings and rotor blades and stuff like that. Good. So there's a perfect example of that depth of knowledge, isn't there? So we can think ahead. Right. So we were talking about just engines. How about we sort of said they've got 2 spark plugs in that cylinder? Constantine,
Because
is
if one fail, then the other may.
there's one cylinder off of, this is basically an R22 and a Cadbury G2 and an R44 engine. It's all basically the same cylinder. 1.5 litres, big old lump. Very basic though, air cooled, and just 2 valves. It's not it's not like most car engines with multi valves. It's just one inlet, one exhaust valve, but 2 plugs. Like an Alfa Romeo. A lot of Alfa Romeos used to be twin sparks. Sorry, Sophie, you're saying?
We're saying that there are 2 because if one fails, then the other will be able to spark.
Yeah, good. And we quite often call that, if we've got 2 of things, you could say duplex, but we usually call it, yeah, that's it. I saw James's lips move. Yeah, fail safe or redundancy. All this, we quite often say, just call it fail safe. So if it fails, we're still safe because something else is probably going to, with a bit of luck, still be working. So 2 plugs. But there might be another very good reason why there's 2 spark plugs, not just purely for the safety
It's a large
aspect.
cylinder.
Yeah.
1 spark might not quite.
Yeah, if we were to look at the math of how long that piston is in the correct position where you really want to ignite that fuel and air, it's not there for very long. It's only a fraction of a second. And so, yeah, 1 spark, although electricity moves incredibly quick, but the time it takes to combust that area, and that's quite a big, even when it's squished, it's still relatively a large area. So 1 plug, igniting it on one side almost, yeah, that's not very efficient. And we do indeed see that. So when we test these ignition systems, making sure that they both separately work, 1 plug at a time, as it were, 1 set of plugs, yeah, the engine runs a bit slower and a bit rougher, especially the 4-cylinder ones. The 6-cylinder, it's not so obvious. Yeah, it only runs a little bit rough and just drops a little bit of RPM, but the 4-cylinder ones drop a bit more. So therefore it's performance as well. So it'd almost be true to say if you stuck another plug or another 2 plugs, it'd probably be even better. But there comes a point whereby it's not going to make that much of an improvement. Then you get into more complex systems.
Basically, the internal combustion should be equal well, it will be
I-
almost equal. in
Yes, needs to be
the-
as equal as possible, as quick as possible. Not too quick, but
Yeah, instantaneous.
yes,
All over the place.
pretty much instantaneous, rather than a burn across the
burn
top of the
across.
cylinder, for instance, across the piston. Yeah, so 2 plugs, primarily really for safety, but also for that performance as well. Jolly good.
How often do you check them? The annual maintenance?
Oh, we don't. We just hope they keep going.
So when is like, what is it?
Annual would be lovely.
Annually, just annually would be nice, wouldn't it? Well, we give you an idea. We change the engine oil every 25 operating hours, which if you turn that into your car that you maybe drive once or twice, commute to work and back home, that's roughly about 2 weeks or 1 week or something ridiculous like that. You know, most cars, people don't service them sometimes for more than a year at a time. Or the engine oil is getting changed every 25 hours. It's the aircraft's being inspected every 50 operating hours or 6 months, whichever comes first. And then there's other things. So it kind of goes in, roughly speaking, it's 50-hour cycles. So if you think it's like a 50-hour, 100-hour, a 50-hour, it might be another 100-hour, 50-hour, then the 300-hour. So some of the bigger jumps are 100, 300, 500 hours. Annually, that's a bit of a bigger thing as well. And there's a lot, heck of a lot. Yeah, it feels like there's literally one there almost every week in having we've literally just picked on one up this morning. We'll drop one off and pick one up.
Yeah.
Yeah, but by the time we're picking that one up, there's probably another one that needs to go as well. Oh God. So
Is it
yes.
the same whether it's a lesson aircraft or just for an aircraft? Same
Well, there's a good question for another time.
Yeah.
No, not necessarily. So if your aircraft is just operated purely privately, and there might be a bit more to it than that, then yeah, it's possibly the owner that can do the maintenance as well. But generally speaking, they've all got to be done certainly annually and potentially every 6 months as well, whether you've flown it or not. Yeah. Regardless of how many hours you've done, where it's just sitting in your hangar and that it's still got to be done. Yeah. Absolutely. Okay. Something in what else can you tell me interesting? We haven't got off of engines yet, but I like engines. What can you tell me about something interesting about the ignition systems in these helicopters? What do you reckon?
Redundancies again.
Yeah, this redundancy, this fail-safe. How do you mean?
Two systems.
Yeah, there's 2 systems for a start off, so it'll run off of each system. And something else that's very interesting about these systems, these things that can generate the spark, is a magneto. Good, Constantine. Yeah, excellent. What do you know about magnetos?
Oh, I know it's
Charles Xavier's enemy, and actually best friend. I said he's Charles Xavier's enemy, but best friend. Sorry, I do apologize. Sorry, go on.
Well, basically, it is a redundant system, but also it's about network power supply. So it helps keep the constant power.
Yeah, that's it. So these are magnetos, which is a black thing bolted onto the engine. Does it need power to make it work? That's a trick question, by the way.
I know it becomes mechanical once it's on.
Yeah, very good. Yes, so it needs mechanical power. So you've got to turn it. So once you're spinning them, they're really just a little dynamo.
It's a generator.
Yeah, that's it. Yep.
Alternator type.
Not yes, but an alternator does need a current to make it work. So it's like an old dynamo on an old engine. A lawnmower has magnetos. You know, there's no battery. On the old ones, you pull the cord, you spin the thing round, it generates. Hey, look, come on in, matey.
So basically, started by spark, and then you maintain it by magneto.
So these magnetos, as long as they're spinning, I quite often most people have possibly ridden a bike with this old dynamo. You put into the wheel and it spins and it makes the light work. You know, there's no batteries. So that's more or less a magneto, but there's a bit more to it than that. That's just the electrical generating part of it. So it can generate its own electricity, which is good. So it doesn't need a battery, doesn't need an alternator. It just needs to be spun by the engine. So you've got to get that bit going first. Then in the top half of them, there's a distributor. Anybody who knows old cars with distributor realize, oh, yeah, there's a rotor arm, points and condenser. It's not electronic ignition, etc., etc. So they can generate their own electricity, and then they can send it out down an individual lead to a complete set of spark plugs. 2 of those magnetos independently supply their own set of spark plugs. Fantastic. Okay, so really old, ever so old technology, but it's very well proven and tried and tested, and it's great because if you were to have an electrical failure of your helicopter, it still runs. Only downside though, the Cadbury. Look at Grant because he's got one. There's a slight downside on the Cadbury. It's not that much downside. Don't worry. I can see Adam thinking I'm not bloody flying one of those now. Give me an old R22 any day. Yeah.
You're definitely learning.
The Cadbury G2's got a magneto. Good. So if all electrical power fails, it's got a magneto, so the engine can carry on running. But it's got a plasma ignition, electronic ignition. So it's got a couple of coil packs, just like on cars. But they do require power to make them work because there's no spinny bits inside them. They're all electronic, but they generate a more powerful, cleaner, more controlled spark that makes it actually work a bit better. So the Cadbury G2 more or less has the same engine, the Lycoming engine as the R22. So if you compared our R22 Beta 2 Cadbury G2, the engine is virtually identical, but the Cadbury's got electronic ignition, so the engine can put out more power.
Right.
And it needs to because the Cadbury's a bit heavier.
On that, was that designed by Bruno or was that designed by Lycoming?
What's that? The
electronic ignition.
that electronic ignition. Oh, you're asking me now. Hello, Sarah, you right? Oh, sorry, bear with. Somebody take a hot seat.
So if he said a magneto, does the Cadbury only have one magneto as opposed to two?
I think it's one, but does it have two?
It's got the plasma.
Does it have? It's quite a
So
big
it's got-
thing. So I don't know if it's two separate things, two per cylinder.
Okay,
No, because I've had mine changed. It has to be changed after certain.
yeah.
Like these things just crop up. You get a big bill for it.
Yeah, it's one magneto, one plasma. So one is electronic, one
Yeah,
mechanical.
yeah, so it's not two magnetos and a plasma.
Yeah,
It's
so
one big
the Robinsons is two
I
magnetos.
think didn't you
Yeah.
say the one magneto has two sets in it? One does two sparks, the other
Yeah.
has two sparks.
Okay, yeah,
Because I remember when they changed it, they have to reset it and time it correctly. And if the time is out, it just the engine just doesn't run properly. So it's like it's adjustable.
yeah.
So they undo a bolt and they have to get it just right for the engine to run properly.
Is it easy for maintenance around here for the Cadburys?
Yeah, there's a few options there. Yeah. HQ where Paul takes his, and there's another place at Wickham.
It's easy to get oil in.
Where do you go?
Yeah.
HQ, yeah, I'm thinking of changing.
Yeah.
Yeah. Yeah, the services. I didn't have a great experience last time. It's been great until last time, but they did it for like almost a month for 100 hours when there was no issues with it.
Yeah, definitely need a plumber.
Yeah.
Meantime, I'll fix it with a bit of tape. Sorry, the hose.
Right. Yeah.
James, are you free for a minute? You're not cooking at the moment, are you? Or are you eating?
I'm not cooking anymore. What do you want?
I'll talk a bit more about electronic ignition and stuff.
In the car if you
Oh,
need
you're gonna-
something.
Yeah,
Pretending like I remember any of it.
I'll cover the
Yeah,
sensor.
cover up the sensor so it doesn't try and flush.
Yeah.
That's the quickest way we can stop it from doing anything. Thank you.
Getting worse, isn't it?
Yeah, she's just
Quite
Sarah's
bad
saying it's
before.
actually they are overflowing.
Yeah.
Yay.
You need e-guide to know.
Yeah, so I'll be swimming down there.
What's
Right,
going
sorry.
on? The bog's given up.
Yes.
Yeah.
No, well, no. No, this is well, it's not aircraft general knowledge, is it? There's two problems. There's too much water coming down from the system, and also it doesn't drain away quick enough, so the urinals overflow.
And no one can work.
Wonderful.
And none of the plumbers, they all could go, oh yeah, that's not good, is it? But we just sent Ross down there with a hammer. Okay.
The boss will be straight in there.
Yeah, unfortunately, he didn't come in the van. We tried calling him. You come in the van by any chance? With his tools. Electronic ignition. Yeah. So the only downside is it needs a power supply. So therefore, it's got to have a magneto as that redundancy, that fail-safe, that backup. But the engine runs a bit smoother, a bit more powerful, etc., etc.
And is that how the Cadbury gets the power?
Oh,
upgrade
so you're
over-
asking, did Bruno design it?
And also, is that how a Cadbury gets the power upgrade over the 22.
Yes, that's it. Yep. I'm to understand. They had to just prove that the engine would be fine with that. It's like the cooling system on it, but yeah, it's absolutely fine. I didn't have any problems with it. There's just the quick version.
So it's a Cadbury ignition system, not a life.
Yeah. So I think Bruno designed the actual controller for the ignition system. The coil packs, to be honest, are probably just from the motor industry, because the spark plugs certainly look like it. They're just NGK plugs, and the HT leads literally look like they're just from the motor industry, probably off of a Citroen or a Renault or something like that. I'm just guessing with that part of it, but certainly that's what it looks like. So a lot of the components are probably just already available. They wouldn't have made them, but I do believe the control unit is their own, because they wanted to make sure it did exactly what they wanted to do at the right time and so forth. Yeah.
Would it still be for the spark plugs, still specific spark plugs that you do?
You can't just go, well, you're not meant to just go into Halfords and say, oh, can I have a set of these, please? Chances are they probably have them. They literally are just NGK spark plugs. Whereas these ones are in this cylinder. These are they're made by Champion, these ones, but you wouldn't find those in Halfords. No way. You wouldn't find them in any car. Quite
So
different.
how come they've got different fuel ratings? Like I know the Cadbury can use standard fuel, like high octane, and then the other, but they both primarily use avgas.
Yeah, pretty good.
Right. So how come that the Cadbury can do that? There's some engine, etc., etc.
Okay, so potentially how many different avgases, that's aviation gasoline, not turbine fuel, so petrol, how many different ones potentially are there? Any idea?
Sorry, what was
Tony, Ross, how many different avgas grades are there? Avgas. You would not have come across them all. I haven't, that's for sure either. But there's probably, there used to be, I don't think you'll find them anymore now, but there used to be, and color coded as well. There used to be a red one, which was basically not good. That's 80. There was a green one, which is
Russian.
Russian.
In Russia, don't they call it?
Oh, do they? The 130 octane rating. Yeah, it says 130, so it's all to do with usually octane rating. There's a blue one. Yay! With an octane rating of
100.
100, yeah. And it's classed as LL, low lead. Not sure about that. And then what other one is sort of becoming far more common now?
90.
91 UL, unleaded.
I thought it was 95.
No, 91.
Yeah, that's the premium at the pump.
That's it. No, well, the proper premium is 99, isn't it? You get the Super Plus unleaded at Tesco's, it's 99 octane rating.
Yeah. So you can use that in the Cadbury then, in theory.
Yeah, absolutely. The Cadbury will run on just about all of them, apart from that really low one, which I just don't know I've never seen it ever. So yeah, it'll run on the 91.
Then what's the...
Well, they can.
Oh, they can, but it's not rated to.
It's just that the older engines, you'd have to have the exhaust valve replaced and also potentially the valve seats as well, because they couldn't cope with the heat.
So the 99 at Tesco's is almost as good as the 100.
I'm recording this, so I might have to pause this now. Yeah, absolutely, yeah. So
it's not cheaper in Tesco.
Oh, yeah.
So when I take my Bowser down to North Weald and I'm spending £2 plus a litre, I might as well just go to Tesco.
What do you think Mogas is?
Yeah, but it's lower. It's 95, isn't it?
Mogas.
Yeah.
Yeah, where do you think it comes from? It's just,
I
motor
get that,
gasoline,
but
isn't
on the
it?
Cadbury, that's going to give you lower power, isn't it? Whereas, are you suggesting?
No, I'm not suggesting anything
Are you
whatsoever.
suggesting that I wouldn't notice the difference between 99 out of Tesco's.
Not a chance, other than the colour.
And it wouldn't affect the fuel gauge.
Ah, yes.
And the landing
Ever so,
forecourt.
ever so slightly.
Well, no, but I've got a 200 litre Bowser that I fill up at the airfield and keep at home.
Now, whether you're allowed to do that or not is another matter, isn't it?
What? Fill the Bowser up at Tesco?
Yes.
Oh, yeah, that'd be fine.
Well, I didn't mean that, but there are rules on that. No, I meant whether you're allowed to use in your helicopter or not. But you're operating privately, so you fall into a slightly different category.
What? So using the Moga, the 99 from
Tesco
Tesco's in the
Tesco
helicopter?
special.
It's a bit like
Every
just.
little cans.
It's a bit like, well, the engine needs some oil. I haven't really got any, but I've got some in the boot of my car.
Yeah.
It's engine oil, but are you allowed to use it?
You mean from a tax or a revenue perspective, or
Not so much that, possibly insurance it could affect. Oh, we're going off.
No, but the
Oh, we're going off
Cadbury's
down
waiting
wormhole.
for-
aren't
the
we?
Cadbury-
Put a Jet A1 in your car, it's much cheaper.
Yeah, exactly. Yeah.
Splash of oil in there as well.
Rated to use it.
It's whether it's approved.
It is, isn't
That's
it?
that's the
You've
key.
still got it on the.
Yeah, but it's
it's
not.
in the- it's
It's
in the-
not really approved for you to go down to Tesco's and fill up the barrels with 99 from Tesco's. Why?
But I mean,
What's the
James Bond
difference?
James Bond can do that.
James Bond, yeah.
James Bond can do that. Yeah.
I guess it's not checked over. It could have stuff in the fuel.
Very
and-
good. Yes, it's not just purely about the octane
Yeah.
or the fuel or
It's the
the
quality.
additives, it's the quality
Yeah.
control behind it, isn't it?
Ah.
So, for instance, when we buy a box of oil, you don't see if you buy a single bottle. When we buy a box of oil, it's got bloody chemical analysis and all sorts done on it. It's all been sampled. So
Right.
it's very strictly controlled, and therefore it's now the approved grade to go into your aircraft. It's really the same with the fuel, certainly for what we're doing. You can't just go and whack any old thing. I mean, gosh, you take a turbine engine, you can virtually run that on anything if you are careful, but you might have to you might have to have the engine replaced. But yeah,
It's like diesel. I got diesel bug in my boat, getting it from the petrol garage. I should have got red diesel from the marina.
yeah.
And it's like the engine.
Oh yeah, because it might have ethanol in it, those sorts of
Yeah.
things.
Even if it's,
Anyway.
Even if it's running on absolutely anything, the what do you call them? The for safety, it's in the gauges. Is it the gauge? It's either made of not silicon, of rubber.
Yes.
So that's a very important thing.
Yes, it
The
is,
oil
yeah.
that you put in it might be acid for it.
That's right.
So
So you talk about seals in the engine, all these sorts of things. That's right. Yeah, absolutely, Constantine. So the nuts and bolts of it is, whilst the engine, the Cadbury, the R22 engine could probably run just about any unleaded or leaded fuel. It's whether you are allowed or should use it for one, safety wise, which is always the top priority, but whether you're even allowed to, because it's not approved. So you've got to be a little bit careful. So it's only approved grades, of course, isn't it? It might affect the Cadbury fuel gauge because it's a capacitance gauge.
Yeah.
So it measures the sort of resistance or the conductivity of the fuel to try and work out how much is in there rather than a physical float level. These sorts of things.
Okay. So
Yeah.
that affects it. Well, the octane level affects the pressure. But
That's why
But
you
the
put your 99 in.
Yeah, because it's not a classic float valve in there. It's not a has everybody seen a float valve, fuel sender? Because we've got them down the end otherwise. Yeah, it's got a stick inside, then it literally looks at the conductivity or the resistance of the fuel in the tank to fathom out how much is in there.
So is it
And this can be
correct that
incredibly accurate.
In the pilot operating handbook, there's a correction factor if you
Yes.
put MOGAS in it, because it's quite distorted with,
Yes.
with 95. If you put 95,
Yeah.
it's quite distorted.
Yes,
isn't
that's
it?
right. Yes, you've got to, it's up above your head as well, the placard.
That's it,
Just
yeah.
to remind you, your fuel gauge is basically going to be incorrect. It's going to be inaccurate.
Is that what you usually say that people discuss it?
No, the octane is really just about how quick it burns. The fuel also, weirdly enough, even though we're trying to ignite it with two plugs, it mustn't burn too quickly, be too explosive. Otherwise, everybody heard of pinking, knocking on the engine? Certainly old cars, you put your foot down it, clatter.
Folds.
Yeah, that's it.
Yeah.
Yeah, that's it. Yeah, Pinto engine used to do it terrible, didn't it? That's kind of, if you've got the wrong octane rating in there, doesn't like it, doesn't burn very well. Anyway, so you can see how deep you can get into some of these areas, these subjects, which is good. It's really good. Gets you really thinking about it. Again, you realise, whilst you could use another grade of fuel, it might not be a clever idea. Might be bad for your engine. It might cause serious problems, which is not very safe. Insurance, ruin your engine. Could affect seals in the engine. All these sorts of things. So probably best use the right stuff. Okay, so moving on, let's move on from engines then. There's obviously lots more to talk about with the engine side of things. How about just a quick description maybe of the electrical system of a helicopter? Just a nice simple one, like an R22. What's it got in its electrical system?
We'll have a battery.
Absolutely, it's got to have a battery, isn't it?
Battery.
What's the battery for though?
Battery for?
Yeah, what is it for? What purpose?
Start the
It's
engine.
surprising actually how many people don't know.
Charges the alternator as well, doesn't it?
Alternator charges the
It's the other way
battery.
round,
Yeah,
yeah.
It charges the
Yeah.
battery.
Yeah. Because an alternator only works if it's spinning.
Mm.
So if your engine's not running, the alternator's not working for a start off. So where's the power coming from? Well, it's coming from the battery. So it's to get it started, isn't
Get it
it?
started, yeah.
Yeah, and to run anything electrical until you see in the aircraft, we have control over the alternator. You can turn it on or off. So it's not always like a car permanently working. You can control when you want it to work. So we tend to start with it switched off, and then we turn it on. So therefore, everything's running off the battery. So therefore, when an engine is running, is it using the battery with the alternator switched on? Is it using the battery?
Yes.
Well, yes.
I thought you
No.
were using the
No.
alternator.
It also charges the battery, and it'll be drawing the power from the battery to run the system, surely.
All right. So
Oh,
if you think, a bit of a hands up, if you think when the engine is running normally, the alternator switched on, it's all working normally, is it using the battery? Yes, stick your hand up.
But the engine's probably not using battery, but the systems inside are using the battery.
Is the battery being used when the engine's running under normal operation? Anybody want to say yes? Who wants to say no?
I'll say like the
Tony's not putting his hand
No.
up.
in the sense of like, so if I
It
was,
would surprise you. I don't suggest you go and do this, but even modern cars aren't too happy about this. But you get one of those engines running, you could literally just disconnect the battery and
yeah,
take
so
it
I've
off.
done this in the boat, but I'm talking about the systems, like the navigation systems and things like that. Surely they would shut down if you disconnect the battery, or might be.
No, it should. Well, there are possibly some things that might be hardwired straight to the battery, but don't forget it's supplying a bus bar. So battery goes to there and the alternator, and usually virtually everything comes off of that, which means, yeah, you can. I've done it many times with cars. You can literally take the battery off when the engine's running,
Yeah,
and it will still run. The alternators aren't over keen on it, certainly on modern vehicles. But if it had an old generator, like a dynamo, an old Volkswagen Beetle was a great thing, because you could actually get one of those running without a battery. You just push it and you bump start it at a dynamo, and away it went. It would now run everything, and you could drive it with no battery until you pull up and switch the engine on. So it's dead again. Yeah.
Because I recall when I had my battery changed, the guys was changing, they were saying, you run the engine, you don't switch it off. And once the engine was running, he changed.
Formula,
Yeah, you can. It's a bit naughty, but yeah, yes, right. You can change the battery.
Formula One cars don't have batteries, do they?
No, because
They
it's
start them.
that's right. It's just weight. Otherwise, yeah, it's just
weight,
another. It's a
yeah.
lump of
Once
potentially
they're
lead.
running, they're running.
Yeah, so it just all runs off of a generating system.
That's why.
Yeah.
That's why in the 44, because I don't know for the cavalry, but the only emergency procedure is on the alternator and not the battery. There is nothing about battery off or something.
Well, see, funny enough, we've been doing this today with the guys doing the type rating in the Jet Ranger. In flight, if you have potentially, although it doesn't have it now, the Jet Ranger used to have NiCad battery in the front of it, right in the nose of the helicopter. And back in the day, got to wind the clock back a bit. Remember, the Jet Ranger's kind of been around since the 1950s when it's in the US Army, when it's developed for there. A NiCad battery was kind of like state of the art. It's like, flipping it, this is good, isn't it? Blimey. And the NiCad battery had some quite good qualities. It could pack quite a punch, certainly back in the day, as it were. But there was a bit of a downside of NiCad batteries, and we sort of see this now with modern lithium polymer LiPo batteries, and that is they get thermal runaway. So a NiCad could suddenly overheat, and it gets hotter, and the damn thing will explode on you. So therefore, you had to have a way of A, measuring the temperature of it to tell if it's getting hot, and then B, isolate it.
Little thermistors in them, didn't they?
That's right. So in all the helicopters, we've got the ability to isolate the battery from the charging system, so that we can, if you've got a problem, you can turn the thing off, can't you? Like an electrical fire, for instance, we can turn certain things off. We can isolate. Oh, geez, what were we talking about? We were talking about the running off the generator, etc., weren't we? So yeah, we A, need the ability to isolate that battery, but B, the understanding that when the engine's running, it's all running basically off the alternator in the 22 Capras and 44s and things, or the generator in the Jet Ranger, and therefore it's just recharging the battery, ready for next time. Now, there's a small element of truth that if you manage to overload an electrical system so much so that the alternator or generator couldn't actually put out that many amps, you would also now be drawing it back from the battery. So it's a bit of a backup. But the idea is normally the alternator is more powerful, will deliver enough amps to cover everything switched on. So it'll never be overloaded. That's the general idea anyway. Okay, so yeah, the battery's just there to run electrics while your engine is not running, get the thing started, and then you take over with the alternator and it recharges the battery. So therefore, probably on this electrical system, is we now know you've got battery switch, you've got an alternator switch, obviously switches for various things in the aircraft, lights, etc., etc. But what else do we got within that electrical system? Maybe to do with the charging.
The charge indicator.
Yeah, some sort of charge indicator, isn't there? Commonly known as a ammeter. Yeah, because an ammeter, what does it show? It does. Yeah, and it shows the flow. Quite often the direction, if you've got one that's got a needle, it can point which way it's flowing to or from, can't it? Cadbury's got one, isn't it? On the screen, it shows whether it's typically they've done it nicely green for good and amber for not so good to tell whether it's flowing to the battery or from the battery. So we see, therefore, as we turn electrical items on, we load it up, we can see the load on the alternator, but it shows which way it's going. So we know, therefore, it's still supplying the voltage, supplying the power and the amps. Something slightly different on the turbine. I'm guessing the squirrels, because I don't fly the squirrel, James. Have you got a load meter?
Yes, yeah. Above your head, you've got basically it's a dial, and you can change it from voltmeter to ammeter on both the generators.
Yeah, that's it. So on the jet range, there's a load meter. It actually, funny enough, it actually shows the loading on the generator rather than how many amps. It just shows how hard the thing's working, and we've been measured in percentage up to 100%, for instance, rather than how many amps it's pumping out. So if it's not working, you just get zero. You know, there's no load on it. That can't be right because there's always going to be electrical load on it, unless you decide to switch it off. Good. Okay, so there's roughly a very quick electrical system, battery, something to recharge the battery, an alternator. That's going to have an ammeter on this, so we know the damn thing's actually working. It might or might not have a voltmeter to see how many volts there are. A lot of them don't have a voltmeter. I mentioned something about a bus bar.
Ignition or something?
Well, ignition's, yeah, it's part of the kind of electrical system. Yeah, absolutely. So some sort of ignition system, but we've already discovered in the Cadbury, in the 22 and the 44, that entire ignition system is completely separate from this electrical system of the battery, etc., etc.
You have like the buzz will be like the consumer unit switches.
Yes, that's it. Yeah. So therefore, you're going to have protecting those electrical circuits, fuses, but we don't tend to call them fuses. There are some fuses on the Robinson.
Circuit breakers.
Yay, circuit breakers. Trip switches, but circuit breakers, we call them CBs. Unfortunately, also CBs are cumulonimbus. Anyway, yeah, some CB circuit breakers. And occasionally we use them a bit like switches sometimes. Yeah, literally we pull them deliberately to control that, whether we have make or break that circuit. Yay, all right? Good, good, well done. That's it, we'll have a look at that Friday morning.
I'll put this in the shredder.
Yeah, stick it on my desk. That'd be great. Thank you. And I'll be in contact Friday morning for you. Come nice and early.
Yes.
I've got quite a busy day Friday morning. That's Lee and Derby. Yep, test day Friday. I just said Thursday. Sorry, Friday morning. Come nice and early Friday morning. Jesus, get me thinking now. Sorry. Yeah, it's Friday morning. So this electrical system, yeah, circuit breakers in there, a bit like trip switches of your house. So if there's a short or too much current being drawn, it will pop, and we can see it's popped, and it cuts the power supply, doesn't it? So it helps protect that circuit. Good. Anything else on the electrical side of things on the system?
Earthing?
Yeah, but it's the aircraft's negative earth. If that makes any sense.
Right. Birds don't get fried, do they? So.
That's right. Yeah, exactly. Anything else? See you later, guys. What up?
The radio's in there, but is that classed as part?
Yeah, that's separate. That's avionics. Yeah. I mean, there's other little bits and pieces, but that's kind of the nuts and bolts behind it, isn't there? Good. So we've looked at engines, looked at sort of electrical systems. What about gearboxes?
Yeah, let's have some.
Drive system, transmissions. So we're going to get that energy, rotating energy from the engine We've got to get it up to the rotors. Now, thankfully, the rotors are also rotating, so it's not like we've got to turn it back into reciprocal motion or something. So we might be able to transfer that energy off the end of the engine via some sort of a pulley system, maybe, probably with some belts. Could be.
CVT type system. Was it? I thought.
No, yeah, that's right. It's not that. That's Catherine. That's Catherine, my wife's trying to join. She's obviously having problems. Oh, Zishan. Hey. Hey, hello, Zishan. And little
Hi,
Zishan.
how's it going?
Yeah, good. You right?
Yeah, been a while.
Good to see you. It's not just me, Zishan. There's quite a few people.
Oh, hi.
But weirdly enough, there's still pizza left. I still don't understand. There's never normally pizza left. Yeah, there's still pizza there.
I can't have pizza anyway.
I know. Sorry, Maddie.
Hi, just let you have joined. It keeps telling me I've left.
Yeah, it keeps you keep disappearing, but
I am here.
Okie dokie. I will stop talking about you now then. Yeah, so we've got to transfer that energy from the engine to the rotors. Not just the main rotors, tail rotor. Probably gonna have to pass through gearboxes because the engine might be spinning faster than what we want the main rotor to be spinning at the end of the day. These sorts of things. I mean, take the speed of a turbine engine, that's going quite fast, and that definitely needs to be reduced down via a gearbox. So the 22, the 44, the Capri, what connects the engine to the, we'll just say transmission for a minute.
Governor? No.
Well, that controls potentially the carburetor or the butterfly.
Sticky elastic band.
A sticky elastic band, yeah, belt driven. So the belts on the Capri, it's one pretty wide belt. On the 22, it's two small or narrower belts. On the 44, it's four of these R22 belts. Not that you guys are flying the Jet Ranger, although Tony's not. Tony's had a couple of goes, etc. Any belts in that one? Any drive belts in the Jet Ranger? No, there isn't. No, it's very different. But it's still going to come out of the engine and it's going to be connected to the transmission somehow, isn't it? But it's via a drive shaft on those.
So the Falstaff and Robinson is multiple belts.
Yes, although if one belt breaks, that's not great.
It's must be designed to run on one belt though.
Potentially, but certainly not a high power of any way, shape, or form. They will slip. So really, it needs multiple belts to actually transmit that power without having a slipping belt, for instance.
So one of the emergencies for the Robinsons would be a failed belt, I guess.
Yes.
A low power.
Potentially slipping belt, yeah.
Low power landing.
So the Robinson.
Or is that an auto? Is that what is the?
Well, the chances are you're coming down. So
it's auto rotation. If
potentially, you get... certainly if it can't maintain RPM. Whereas the Capri's only got the one big belt. But if that slips, breaks, or not enough tension on it, there's no backup for it. But that backup is we fly very defensively, don't we? And we always try and make sure we can glide down, auto-rotate down and land the helicopter. That's the whole point. We fly very defensively. So we very seldom put ourselves in a position where we couldn't get out of that sticky situation.
You don't have to take off going up. You always take off.
Generally, yeah, that's right. Yes. But it's I'm digressing a bit, but it's risk assessments, isn't it? It's we call it threat and error management. We look at how things could potentially affect us and go wrong and try and minimize the chance of that happening. So, the chances of the engine failing are slim to non-existent. However, we won't push our luck with it. So we'll only use that reliability every now and then, as it were, and try and minimize the length of time we do it.
Have you ever had an engine failure?
No, not a full-blown one. No, but we simulate them all the time. We've probably done with the poor Lee and Derby, we must have probably done about 20 of them today, something like that. So you get very used to it.
Yeah.
So hopefully it's not a big shock when it happens.
Yeah.
But they are incredibly reliable. As long as we look after them, get them well serviced, and don't use dodgy oil or fuel.
No Tesco special.
That's right, no Tesco special in it.
And the easy thing is just because with the old helicopters, the collective wasn't connected to it. So you had to use the collective.
That's right. Yeah, there was no mechanical link between the throttle and the collective.
How do you actually...
There's a correlation between the two. There's a mechanical link and an electronic one as well.
Yeah.
That will control it electronically for us, so alleviate the workload. But we still have to be capable of flying these things with a lot of things not working.
Yeah.
So when we are on aircraft general knowledge, to sort of put it into our heads, it's a little bit flippant, I know, but I sort of say, you know what? I don't really mind if the engine fails. I can cope. I can cope if the tail rotor fails. I can cope if the electrics fail. In fact, I can cope if all these instruments and all the gauges all fail and the electrics all fail and the engine fails. We can still, if we've been flying defensively, we can still auto-rotate and land. The one thing we really can't cope with is if that lot stops turning or a bit of it flies off, but they're very strong, or we lose the actual vertical and horizontal stabilizer off the back of the helicopter. If we chop the tail boom off with the rotors, that's also disaster. As long as those bits still spinning and attached, and I've got a horizontal and vertical stabilizer, we're in with a fighting chance of landing if we were flying along. It kind of makes you realize, oh gosh, you can actually deal with an awful lot if you fly it defensively correctly, and then your knowledge of aircraft, you might be able to manage with, something's not working properly. Anyway, right. So there's a sort of touching upon electrical systems. There's always lots more to tell you, isn't there? So drive systems. So we're going to transmit the power from the engine to the gearboxes, to the transmission, to the drive system, usually via a belt, certainly the things you're flying, or belts. Good. So these helicopters, 22, 44 Cadbury G2, have got a switch, and it's usually got a clutch written on it, or there's a clutch switch. So how does that work then? Is it the same as what's in a car?
I presume so. Yeah, it would have to, wouldn't it?
There's no reason. There's no reason why.
Far more rudimentary.
There's no reason why you wouldn't have on the back of the engine, a pressure plate, a friction plate, a flywheel, and you're going to squidge the whole lot together. But when you press the pedal, like in a conventional car, you apply pressure to the pressure plate, and that actually releases the friction plate that can spin separately to the engine. So you've got this way of kind of disconnecting the gearbox from the engine and reconnecting it, especially if you've got to do a lot of gear changes. But we're only kind of doing one gear change, if you like. We're just putting it into gear, aren't we? I.e. engaging the rotors, and then when we shut down, disengaging them. So we don't need to keep re-engaging and disengaging this clutch. So it doesn't really need to be that complicated or heavy. So it's all suddenly about weight for a start off, because every single ounce, pound, milligram, whatever is a penalty of some description or another on performance and payload and God knows what else. But also the complexity. The more complex, the more there is to go wrong. So some of the modern helicopters, bloody nightmare, because there's so many, potential sensors and things that can go wrong. Whereas some of the good old, just real basic, this is why sometimes an R22, etc., is quite nice, because it's pretty simple. There's not an awful lot to kind of go wrong as such. Anyway.
On that very note, I was chatting to a guy that competed recently in the Torquay Cows powerboat race, and he was putting his boat in at the marine, and he was competing in the only wooden boat in the race, which was a 1950s.
Somebody else for change.
A 1950s offshore powerboat, but he said he regularly beats much more modern, much more expensive stuff because if his boat is just so rudimentary, and just like twin diesels. It's old, it's reliable.
That's it.
And he said he regularly places above much more.
Might not be the fastest.
Modern. It's not. He said it's definitely not the fastest. But he regularly places above more modern, much more powerful, more expensive stuff, just because his thing will plod on, keep plodding on. So he places because other stuff breaks down. So quite amusing, actually. Pretty boat.
Yeah.
James online there, James. He's flying twin squirrels, so they're quite complex. I dare say you've had a fair.
I have never had more warning lights in my life.
Honestly, really.
A lot of them are non-events, but yeah, I've had all kinds of things now.
Well, ain't there French electrics, which doesn't help, isn't it?
But do you?
Yeah. If the electrics work to begin with, yeah.
Is there not a danger that the more warning lights you get, the more potential there is to become complacent when you do, and there's a risk.
We talk about that.
You get a real one.
You go, oh, yeah, it always does that. I've seen that before. Yeah, it's fine. You can ignore it.
Yeah, that's the danger, isn't it?
That's the danger, yeah.
It's like the fire alarm going off and then you ignore it and then the building's on fire.
Yep, you've got it. Yeah, so you've got to be a little bit careful. What's a false warning and what's genuine?
Yeah.
What's the difference? I mean, there might not be any difference, is there? And yeah, we often talk about that. Got to be a little bit careful with. Sorry, it always does that. It does it, yeah.
Is there like a certain amount you can get away with? Is it like in the pre-flight check you can go, right, if that's failed, it's still okay to go out? Or
Oh,
is it
very
just a no?
good. Yes. Because here's something that it falls within just about aircraft general knowledge.
Not on a pre-flight check, really, is there? If it's not right on a pre-flight check.
Well, yeah, we
you
have
should
minimum equipment lists.
Probably not go.
Right.
But that's correct. Yeah, to be
Yeah.
honest, if it's something that's anything to do with safety, even if it's kind of doable, you probably shouldn't set off.
But when it's in flight, there's different levels of landing.
And if you're away from
immediately.
base, I mean, if you think you've gone, I don't know, you've gone somewhere fairly remote to go and take some photographs, and you jump in your helicopter and something's not working properly. If you haven't got maybe survival equipment, it might not be so good that you're stranded there, is it? I mean, you ought to always cover every eventuality. However, it might be now acceptable to fly that aircraft back to base, so you're not left in potentially a hostile environment because you weren't planning to stay there all night long with the temperatures plummeting, the wolves coming at you. But you can fly back to base. So we have these things called minimum equipment lists, which kind of show what's definitely got to be working. And maybe if something's not working, there's a way of carrying on without that system because you can monitor it in a different way. An alternator's warning light's always a classic, or an ammeter. So if your alternator warning light doesn't work, if you've got an ammeter, fine, you can use that. But you've got to keep an eye on it because there's not going to be a warning light coming on, or vice versa, of course. If your ammeter's not working, but your warning light is, you monitor that all the time. So there's ways around that. That's a minimum equipment list. Certainly a lot of private pilots, certainly owners, have got no idea about that. Their standard answer is you just sort of phone maintenance. It's like people used to say, oh, if there's something working on phone pole, it's like, oh, you're kind of meant to know there's a list somewhere that tells you about what might be acceptable not working. Okay, so we sort of very loosely looked at sort of dry system gearboxes, these sorts of things. We hopefully understand that a gearbox is potentially to reduce RPM or increase it, but also maybe make it this rotational movement change direction. Could be your shaft wants to turn complete opposite directions, or it might be a different angle. So can you give me any examples of maybe in a helicopter where a drive shaft needs to either go the opposite direction or as in rotationally or an opposite or a different angle from the input? So we're talking about inputs and output shafts.
Both gearboxes.
Yeah, absolutely. Both gearboxes. Yeah. There's a horizontal drive shaft generally goes into them and it comes out vertical, or in tail rotor gearbox comes out horizontally, but at a completely different angle, doesn't it? Good. Therefore, you've got oil in them to lubricate it, possibly sight glasses, you can see the oil level, and maybe even chip detectors, which will look for ferrous particles of metal.
If you choose the right helicopter.
If you choose the right.
If you choose the wrong helicopter to have any of those.
Yeah, no, they've got chip detectors. Robinson have got, yeah, of course they have. Okay, so that leads us nicely into tail rotors. So what is without going heavily into principles of flight, because there is definitely crossover, what is a tail rotor? Or what's its purpose? Why?
Fan. To stop the torque, isn't it? Anti-torque. Anti-torque, yeah.
Yes, it's an anti-torque device. For some people, torque is a new term, maybe other than speaking torque, but it's T-O-R-Q-U-E. It's a twisting force.
Yeah.
So because generally the engine's got to, mostly the hardest work it's really got to do is turn the rotor system. Most people have kind of heard of some of the Newton's laws. Every action has an opposite and equal, or an equal and opposite reaction. Well, it's going to twist your fuselage round or yaw it round, causing that torque reaction. So if we get into the Robinsons, it's looking from above, anti-clockwise turning rotors, which means the fuselage, we see it, nose wants to go off to the right all the time. Take the Cabriolet, it's the opposite way round. And yes, it is sort of semi-true. Allegedly, the French did that to get over the patent of the helicopter. There is elements of truth in that story, which is why they turn clockwise, opposite to the American / Russian ones. Anyhow, so it's an anti-torque device to help stop us from going out of control. So one way or another, would it be true to say there's a big fan on the back of the helicopter?
Yeah.
No. Yeah. I was doing that classic being a bit naughty with the question. I just said, is it true to say one way or another there's some sort of big fan rotor thingy at the back of the helicopter? No, it isn't. Somebody mentioned earlier notars. Notars are completely different. There's a big fan, but it's really bolted back down the engine area, blowing down the tail boom with a nozzle on the end, a bit like a hair dryer, but you can open and close this nozzle to decrease the flow out of it. But that's only providing possibly up to, I think it's no more than 25% of the anti-torque. So where the heck is the rest of the 75% anti-torque coming from? I think it's 25% on notars. I have to read it again.
Never even know that.
Yeah, the ones that don't look like they've got a tail rotor on the end of them. But I still only one rotating main rotor, not a counter rotating ones. They're different.
It's a bit complicated to know that. I mean, it's not that malleable, that domestic in regards to it. The Coanda effect is a bit
good. So notice Constantine, you might not be able to hear him. He's just mentioning Coanda effect.
Yeah.
Which is pretty cool. Makes golf balls fly further. It's how Becken can bend the ball so well.
Yeah.
Maybe not nowadays, but you know.
They need to be quite. You need to put the paddle in just before the bet.
Yeah, you have to anticipate a fair bit more.
Yeah.
So the Coanda effect just talks about kind of how maybe when it goes round, something round, potentially almost like a wing in some respects, can generate more lift on one side than the other, blah, blah, blah. Anyway, it uses more or less the entire tail boom with this Coanda effect to sort of pull it round, if you like. It's very crude what I've just said there, so do look it up. Anybody with long hair uses a Dyson hair wrap. That's Coanda effect. It's quite cool to watch it happen. You put it near the hair and it goes round it, curls around it, because it's got little slots of air going round and rotates round.
It's weird because everybody calls it Coanda effect, but it's actually Coanda.
Yes, sorry, yes.
From our Coanda.
Is it?
Yes.
Ah.
The Romanian aviator basically discovered the effect itself. I'm actually coming from the airport with the name today. It's from Romania.
A very, very crude experiment. It's not perfect, but it'll do. Just have a tap with not too much water flowing, just a nice little steady little stream. Put your finger near it. It's not so much static, but it will bend around your finger to a degree. That's a little bit of Coanda effect. There's many examples of this. Okay, anyway. So, but one way or another, we do generally need some sort of anti-torque system because of how hard that engine's working to turn those rotors, as well as a few other bits and bobs. So the helicopters you're flying, you know, the 22 and the Capri, what's that anti-torque system? It's a
tail rotor.
Yeah. Yeah, very good. Yeah. Or a Fenestrum. Surely they're just the same thing, aren't they? I've seen them. They spin round with blades, and you change the pitch on the blades. It's just the same, isn't it?
Yeah, Fenestrum's enclosed.
Yeah. So sometimes we describe as a ducted fan. So whilst it kind of pretty much works in the same way, the effect of it is different, and they both have their kind of limitations. They have their plus points and their not so good points, don't they? So what's
the Fenestrum is not linear, is it?
Yeah, so that's right. So generally, on a conventional tail-rotated helicopter like the 2244, Jet Ranger, etc., the pedal input is a linear output. So if you push this pedal a small amount, you only get a small amount of yaw. You push it a bit more, there's a little bit more yaw, a bit more, and so forth. Whereas the Fenestrum's not like that. You push it, it might do quite a lot, but you push it a bit more, it's not a lot. And then you push the last bit and there's quite a lot. So it's not a linear output as to input. It's a little bit used to. But it depends what you've done. If you learn straight away in the Cabri, no different. So it's normal.
Slow reaction as well. Is that just myth or is that?
Not necessarily. Only if you get into this kind of where, if you were to look at the graph, if you get to where it sort of plateaus a bit, you kind of feel that it's not doing anything. It is. It's just not doing as much as you expect. So it's not a linear, but you learn how to adapt to that. But it's just as weird than if you go from a Cabri into a tail-rotated helicopter. You're not used to it. So that's what type rating's all about.
So in that case, we still have to check it each time.
Potentially, just depends what depends entirely what maneuver you're doing. But the fundamentals, it doesn't matter which way the rotors are turning. It's an anti-torque device, and if you press the left pedal, generally the nose goes to the left. You press the right pedal to the right. It's no different, but it might be different to what you do compared to with the collective lever. You know, for instance, the Robinsons, we teach you lift and left pedal. So you lift and leave left pedal, as a Cabri, it'd be raise and right pedal to help you get ahead of it. Yes, because it's the other way around.
Interestingly, Robinson aircraft, it's more acceptable to turn either way, whereas Cabri would generally teach to turn with the power pedal, wouldn't you?
Generally, but it's a good idea. No matter what helicopter, you just turn with the power pedal. It's it's the safest way to do things.
So you turn
To a degree, yeah. I mean, but the tail rotor on a Robinson is on a very, very long tail boom. So it's got a very long arm. It's also very big compared to the helicopter. So it's just more powerful.
Yeah.
It doesn't need to be that big, but the story goes Frank wanted to make sure he didn't get the big problem with his helicopters. Like take the early Jet Ranger, the tail rotor was a bit too small. Bearing in mind the thing can operate potentially up to 20,000 feet pressure altitude. The air's so damn thin up there. If you let it, if you're heavy and you just start letting it nose you're to the right, you probably won't stop it. It's gone. It's already gone. Loss of turret effectiveness.
What do you mean take off with the power pedal? So the turning with the surge?
It's the pedal you press is you add power, or the pedal that would demand more power. You're adding pitch to the tail rotor.
Right.
So we call it the power pedal. So we would, in a Robinson or any Robinson, you'd use the left pedal because it's demanding more power for the engine, which means A, you always know you've got enough power to complete the maneuver, but B, it doesn't take power to stop that yaw. If you go to the right, the helicopter wants to go that way, and at first it's like, oh, this is good, but then it's off, and it takes a lot of effort to stop it.
So
it runs away with
helicopters you mentioned, they don't have the tail fin to provide the stability once you're underway, like the Cabri does.
Yeah, the Robinsons all do. Yeah, they've still got vertical stabilizer that will help stop the tail from waggling around both laterally and vertically. But also there's a built-in a bit of angle on it, like a rudder, fixed rudder sort of thing. It's really obvious. Look at the back of the Jet Ranger. It's 5 degrees off to the right visually, which means it tries to yaw it to the left, because 5 degrees is about the right amount for when you're bombing along at 100 knots, pulling like 85% torque. It means the pedals, the tail rotor will be on virtually zero pitch. So all the work's done by the vertical fin. That's roughly how they design them, depending on the aircraft. So yeah, the Robinsons do have them, but just a tiny bit of a slightly different design. So has everybody seen the back end of a Cabri, the fenestrum, where it sits inside the vertical fin? So the whole thing is a big fin, but in there's a duct, and the tail rotor sits inside it, which means if you look at the back of the helicopter, you can't see the fenestrum blades. They sit inside, which makes it very efficient in forward flight. So it's very streamlined. Whereas on a conventional tail rotor, that lot's sticking out the side of the helicopter, which causes a bit of drag. So it's just a little bit less efficient. That's all. But tail rotor generally is kind of more powerful than a fenestrum, potentially. But the fenestrum doesn't get loss of turret effectiveness from the certain wind azimuths where the main rotor vortex is going to the tail. So on a anti-clockwise turning conventional tail rotored helicopter, 22, 44, Jet Ranger, all these sorts of things, if we get the wind from hitting us from about a 10 to 11 o'clock at somewhere around about 12 knots, the vortices coming off the main rotor go into the tail rotor and disturb the air sufficiently that it loses its efficient and it yaws off to the right, known as loss of turret effectiveness. And usually you can get it back, no problem. But there are certain scenarios where once it starts, you can't stop it. Okay, there's enough of those for a moment. So moving forward up to the main rotor systems. Loosely speaking, they're all the same. With a bit of luck, there's at least 2 blades up there or more spinning round. So when the rotor blades are spinning round, rotating, collective levers fully down, are they generating any lift?
Not be collected down, no. Yeah, we lift, but not enough to obviously take off.
Anybody want to say no lift? So rotors are turning, doesn't matter which helicopter. Rotors are turning, collectives fully down.
So there is no lift as you have symmetrical. You don't have asymmetrical.
So who wants to say they are generating some lift?
They must be, because the droop goes out of them, doesn't it? Or is that just by the force of them turning that they no longer droop?
Also, there's a little bit of lift.
That's centrifugal.
Right. So you've answered the question.
So Stick your hand up if you want to say they're generating some lift. Again, I'm not going to put mine up.
I said no last time.
Stick your hand up if you think they don't generate any lift. Stick your hand up if you're just not sure. Well, they all generate lift. So if you take a Robinson rotor blade that is symmetrical, it's asymmetrical. So you would assume, therefore, lever down, 0 pitch, no lift. Correct?
Yeah.
So
he's lever down, no pitch, or he's lever down.
Well, there we go. You see,
We're getting there.
we're getting there. So you could go, well, it depends on how the engineer set it up, because it's not set on the ground. It's set for auto rotation for a start off. Strictly speaking, it's not set on the ground. However, let's just say that, for instance, on the ground, lever down at the tip, if you were to measure it, is 0 pitch. They still generate lift. Come on, we're missing something. I wouldn't expect you all to know.
Is it because of the twist?
Yes, they've all got blade twist. You take a Robinson's 8-degree blade twist from root to tip, which generally means the tip's not in negative pitch. That would not be a clever idea, because it would bend the rotors down towards the ground and all sorts of nasty things. But at the root, you've got about possibly up to 8 degrees positive pitch. Therefore, the root is generating some lift. I didn't say enough for flight. I just said generate some lift. So therefore, on the ground, as instructors, when we get out the helicopter, you can feel some downwash. It's not a lot, is it, James? But you can feel a little bit.
Yes, now you mention it.
Just a little bit, just a little bit, not a lot.
And is it that lift that takes the droop out of the
No, it's just centrifugal force. Yeah, it's just pure centrifugal. The centrifugal force on those rotors, take an R22, the force pulling on a blade, I think off the top of my head, is 4 tons. I think, if I remember rightly, at full RPM. So there's 4 tons trying to fling those blades off in either direction.
And that's
a lot, and that's just keeping them flat, isn't it? Literally like that. I think it's 4 tons. Yeah, so there's a bit of blade twist. So what about the Cadbury then? A, has the Cadbury got any blade twist? B, is it asymmetrical? Well, the Cadbury blade being...
I clean them all the time, I should know.
the Cadbury blades being very strong carbon fiber skins with a resin injection inside them, etc., etc. They've actually, like the squirrels that James flies, they've actually got a little bit of a lift generating section. The bottom's a bit flatter and the top's got a little bit of a dome to it, so they do generate a bit of lift by themselves because they're that much stronger, sort of thing. So they can afford to, because we get into all sorts of problems if they generate too much lift by themselves, as it were. So therefore, there, even the Cadbury generates a bit. So we do feel it. You get out the Cadbury, feel a little bit of downwash, not a lot, but a little bit of lift from it, a bit downwash. So there we go. It's another little trick question there. Or I've got some lovely ones like that, but we'll do that for principles of flight. Okay, so the blades potentially could be asymmetrical, but not necessarily. They might have these funny triangular bits at the tip. And that's all to kind of help reduce tip vortices and possibly noise as well, but make them more efficient because there's a lot of energy lost at the tip of the blades. The rotor tips mustn't go supersonic. It's really not good at all if they do that. But again, there's delving into principles of flight then. So what can you tell me about maybe the number of blades? Is there a significance? How many main rotor blades it's got? Ideally the right number for a start off.
I know the Cadbury's got 3, isn't it? Robinson's got 2.
Yeah, but is that just coincidental? Is there a reason behind it? Or again, I wouldn't expect you to know. Just
no, I'm just throwing my ideas out there. I mean, if you have more rotor blades, you can obviously have shorter rotor blades.
yes, good, potentially, that's right. Or you get to a point where you just, if you stick with 2-bladed systems, they get so big. Look at the Bell 222. Wow, those rotors are big and wide, aren't they? But I mean, you're almost at the limit there of what you can achieve with 2 blades.
And also you can tuck it into.
Yes, so it could be a parking thing. It might be done deliberately, so that when you put the blades fore and aft, the aircraft's not very wide, and you can get more into the hangar, as it were. So it could be a reason why.
Is there a difference on the auto rotation on them? Like, is the Cadbury better or?
That starts to come down into more technical design and weight of the blades and various other things. But strictly speaking, no, they all kind of rotate similar to one another.
Performance wise, it would be, well, it depends. On a 2-bladed, you won't have any interference in downwash quite a lot. In the more you have, the more problems you get downwash. With the not downwash, with the induced airflow.
Yeah, maybe. So there's various reasons, you know, because if you just straight away compare, why did Frank potentially design his helicopters with 2 blades, whereas Airbus / then Bruno, for instance, at least 3 blades?
Frank was trying to build a cheap helicopter.
Well, there is that without a shadow of a doubt. So it's going to cost less to produce 2 blades probably than 3 blades for a start off, isn't it? There's definitely less to do, isn't there? There is that, first of all. So I doubt it was purely, because I want to park more in the hangar. That's more like just a bonus of having a 2-bladed system, isn't it? Almost. You wouldn't, I don't think you'd deliberately design your helicopter like that, because 2-bladed systems aren't necessarily as good as multi-bladed systems. So we're going to call them different things, first of all. We're going to call them, a 2-bladed one can have various names, teetering, semi-rigid, but it describes that all that lot seesaws, one way or another, it seesaws on the main rotor mast. It's not rigidly attached on a 2-bladed system, so it seesaws or teeters. So they can flap, they can feather, but they can't lead and lag, so they can't move independently in their position compared to the other blade. Whereas multi-bladed systems, 3 or more, don't matter how many blades, they they flap and feather, but they also lead and lag, so they can jostle for position, and they have to. Otherwise, it's a big problem known as Hooke's joint effect to overcome a big issue of imbalance. Anyway, but why would you? Come on, there might be some more reasons. Why would you have a 2-bladed system versus a 3, or a 3-bladed system versus a 2? What type of rotor head is a 3-bladed or more? What do we call that? Fully articulated. What is that kind of? I've just told you it means they can lead, lag, flap, feather, lead and lag. But the lead and lag is really to overcome a problem. You wouldn't think, because I want them to lead and lag. It's just to overcome an issue. So why would you maybe have a fully articulated rotor as opposed to a 2-bladed rotor? And if you can answer that question, it'll answer why there's a particular helicopter that is one I'd definitely like to have out of all the other helicopters.
More blades gives you more stored inertia.
Possibly.
More weight.
Yeah, possibly. Yeah. Come on.
You don't have to worry about mast bump.
Good, thank you. There's this thing called mast bumping. Don't want to be worried if you're in a 2-bladed rotor-headed system, but you need to be a little bit careful because this hub sits on the mast and can teeter. There are certain occasions where it can teeter a bit too much and it hits the mast, and the force could be so great it can snap it clean off. At that point, everybody goes, I'm not flying a 2-bladed rotor system. But if you know about that, so the depth of knowledge, you ensure you don't do certain maneuvers that won't cause that to happen. You stay well away from that.
Surely there was a way for him to design that out, right?
No, it's not possible. Yeah. No, it's not possible. It's got to teeter because
they almost put a stop on it.
Oh, they do have stops, but the force. I did the safety course, and Dick, I can't remember if he did I think he did the calculation. You realise, oh my God, the snapping, the shearing force. It's just no way even the solid mast will not withstand it. You can put all the bump stops you like on it, it will just break it clean off. If it doesn't break the mast, it'll just shatter the hub. The force is unbelievable. You've got to remember the centrifugal force on those rotors, potentially 4 tons or greater. That's just on an R22. It's a hell of a force. And the force of the weight of the aircraft. Anyway, yes, it just snaps it clean off. If it doesn't do that, it chops the tail off. So either way, you're doomed. So mast pumping. So if you don't like the idea of mast pumping, or you want your helicopter to do things that would normally be not such a great idea in a 2-bladed system, you need a fully articulated.
With the 3 rotors.
Yes. So therefore, not approved, nor the rest of it, but theoretically, pretty much most multi-bladed, therefore fully articulated rotor system helicopters can loop and roll. Whereas the 2-bladed ones, it's a very risky maneuver because you'll probably lose the rotor head. So then it delves into the Red Bull helicopter, the Bulco 105, the one that does the flips and the loops and the rolls and all the rest of it. That's a fully articulated with a whacking great titanium rotor head. Yeah, old helicopter, but my God, it's half capable. Fantastic bit of kit. Anyway. Beth says hi, by the way. She says sorry she can't join us. She's been away on holiday, one thing or another, but says she wanted to come tonight but can't make it. But she's saying hi. So there's a whopping great difference there. We are teetering versus fully articulated. So teetering is potentially less complicated, not as expensive to produce, easier to park in the hangar, potentially easier to or smoother to hover. So what's the squirrel like to hover, James?
Squirrely.
Squirrely. Everybody says they're squirrely. It's like, what do you mean squirrely? Bloody twitchy, you know.
It is wobbly. It's got its own little air systems underneath it. Hardest helicopter I've ever had to land, actually.
Yeah, you see them when you watch them land on the helipad. They come in all looking quite graceful and quite cool and smooth, and then they try and land, so wibbly wobbly, get it down quick. Yeah, the cab.
That's what we blame it on. It's definitely aerodynamics and not dodgy
aerodynamics.
pilots.
Yeah, it's not pilot injuries. See, the Capri's a little bit like that, isn't it? A little bit.
Yeah,
Whereas you fly a big old heavy two-bladed like the Jet Ranger, the thing just kind of just sits there in the hover. It just sort of gently might just waft around gently, but it doesn't twitch and wiggle around. It just kind of sits there. Even the 22 does that to a degree. So there's maybe that advantage, which is why we often say, like to Adam, try both, see which you prefer. It might not just be all about the looks of the aircraft and
they do look good though.
That's right, they do. Yeah. You might find you don't get on with it.
Look good.
You might find it's too twitchy, too lively, doesn't suit you. But anyway,
looking good.
I don't know if you can hear what Adam's saying. He says, "Well, at least if you go down, you're going down in style in something that looks good." He was a carbon fibre helicopter, you know, with a little glass screen. As he tries to do his loop and roll in it.
Yeah.
Okay. So yeah, there's quite a few differences there between that two-bladed or three-bladed, more multi-bladed system and fully articulated rotor head. Good. Okay. So what else we got on aircraft general knowledge? Anything else you can think of?
What about, I've seen some, I don't know which one, but a helicopter with more than two blades, and actually they stay on the ground, and because of that, there is the ground reasoning or something like that. And so the helicopter just crashed on itself on the ground.
Yeah, that's right. And that kind of it delves into principles of flight there a little bit, but it is aircraft general knowledge without a doubt. Yeah, so there's, when we think about how many spinning things there are on a helicopter, there's quite a lot. It's not just the main rotors and tail rotor, it's all the drive shafts, the engine, all. Oh yes, just straight down, constantly. Just keep going. Just watch it. Apparently it's flooded. Unofficially, use the ladies. There's probably nobody in there. Otherwise, yeah, just use the ladies. It's right down the far end.
Right, left, and on the left.
Is it quite bad down there? Slippery. Yeah. Okay. Yeah. There'll be nobody else in the building now. Yeah. So if you're not careful, so there's certain reasons why all these things have been designed to rotate at certain RPMs. It's not just coincidental. What they don't want is these frequencies of vibration to begin to harmonize. So we often know with if we think of harmonization with singers, it's a good thing, isn't it? Because if they're out of harmony, it sounds bloody atrocious. But if they're in harmony, whoa, it's like it's amplified, isn't it? And that's not good in helicopter terms with frequencies and vibrations. So if they harmonize, they amplify, and they can get bigger, and they can get to this thing called ground resonance. But true ground resonance can only happen in a multi-bladed, so more than three-bladed rotor system, not in the. That's right. So the 22s might shake on the ground, but it's usually because you've got the cyclic in the wrong place. Hey, leave it alone, poor little thing.
5 years to come out.
Leave the R22 alone. It's picking on it. So yeah, they don't get ground resonance.
Really?
Yeah.
Never know that.
But I don't know. I'm not going to pretend to know. James, the squirrels, are they particularly prone to it?
You can get it. It can do it. It's not all the time, not that regularly, but yeah, you can slip into it every now and then. Usually off airfield landings.
That's right. So there are certain things that exaggerate this ground resonance. It can be RPM, for instance, of the rotors. So you take the Cadbury, they can start to do it at typically the RPM you use to do the ignition checks. It can start to oscillate round. There are things that will affect that. For instance, how sprung the undercarriage is. So if it's a rigid undercarriage, tends not to allow it to rock around so much. But if it's quite a soft undercarriage, so helicopters with wheels and struts, oleos, they can potentially be more susceptible because there's more give in them. like say the Cadbury, the Gazelle is quite springy undercarriage. Yeah, I've been in one when it's got ground resonance. That's not pretty. That comes on very quick and quite violent if you're not careful. Anyway, that's sort of heading a bit more down principles of flight stuff as well. So one of the things we haven't mentioned, but we haven't talked about, is something we spoke of earlier. That is, what about instruments and gauges? So first of all, what's an instrument? What's a gauge? Alec.
Gauge is mechanical.
Yeah. Go on, Alec.
Instrument will give you a reading such as airspeed, but a gauge will tell you an amount.
Yeah, so Alex saying an instrument will give you a reading like airspeed, whereas a gauge might be an amount in fuel, for instance. Yeah, that's very true, but we can kind of categorize them a bit better than that.
Instrument goes around.
No, nice try, Adam. Yeah.
I think gauge is more like a mechanical device that's very directly connected to something. And it gives you
Not
instantaneous.
Gauges can be electronic.
Right. So it's more instantaneous, right? I forgot the exact difference.
And once you hopefully we'll go, oh, I see. And then on the checklist, it starts to make more sense when it says check the gauges, and then somewhere else it says check the instruments. Oh yes, that makes sense now.
An instrument doesn't have an input, does it?
Yeah, of course it does. Yeah. Oh, I didn't realize this is going to be so tricky. Come on, Tony. Different. Yeah.
The instrument gives you a performance of the heli, whereas gauges are just to show the, I don't know, the temperature or the
Very good. We're pretty much there. So an instrument, you might say, is more like the performance of the flight. How fast, how high, how quick you're going up and down, these sorts of things. Whereas a gauge would be how hot it is, how much fuel it's got, how much power you're pulling, these sorts of things. So that's how we typically divide instruments and gauges. And that's why I say it starts to make more sense on a checklist, because if you're just starting up your helicopter, it isn't necessarily flying anywhere. So you might say, check your gauges, i.e. is the engine warm enough? Is it turning the right speeds, etc. Whereas when you're flying, we might say, check your instruments. How are you flying right now? Are you fast enough, high enough, low enough, blah, 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 in balance, time. So clock's another instrument, isn't it? Yeah. And then it all makes sense because you read stuff about primary flight instruments. Yeah, it's nothing to do with gauges. This is how the thing's flying. And they're usually put right in front of the pilot, the flight instruments, because they're critical for flight, whereas the gauges, jet range is a really good example because it's all in front of you, how you're flying. The rest of it is how the thing's running, etc.
So VSI instrument.
Yes, vertical speed indicator definitely be an instrument. Yeah, fuel gauge.
I guess in other words, gauges are like readings, like they give you readings, and instruments are measuring something.
Yeah, but the problem is, as a gauge, if you take a fuel gauge, it's measuring the quantity, so it doesn't quite work. The best way to describe it is a flight instrument, or an instrument is exactly that. It's to showing you your performance of your flight, how you are flying, whereas a gauge is a performance maybe of how fast something's turning, or the temperature of something, or the quantity of fuel, etc. Those sorts of things. Temperature in the carburetor, that's a gauge. It's not a flight instrument. But airspeed indicator, definitely flight instrument. Okay, so if we look at some of the flight instruments then, how do some of these work? We're just talking more the old tech stuff, nothing too modern, sophisticated. Like an airspeed indicator, how does that work?
Air pressure.
Yeah, air pressure. Need a bit more than that though, but you're right. So in other words, it's not for us, it's not GPS. That's for sure.
No.
It's also not got some little wheel dragging along behind the helicopter along the road, spinning around trying to work out how fast you're going. Because that's how old cars used to do it.
No,
Cable attached to your wheel.
I know it was air pressure, something to do.
Great, we've had a word, pitot tube. Excellent, that's good. The sticking out the front of the helicopter, yes.
It's the difference between the pitot tube, which gives you the
Oh, she's going to take the question. Yeah.
Dynamic.
Dynamic. Thank you, Isran. The dynamic.
Good. There's a question that crops up in the exams: is what does a pitot tube measure? Is it how fast you're going? The tube poking out the front of the helicopter, as we fly along, air goes basically into it or pushes against it. Does it measure how fast you're going?
No.
No, of course it doesn't. Does it measure? Does it measure airspeed?
Dynamic pressure, basically.
The next multiple choice is does it measure dynamic pressure, or does it measure static pressure?
Yeah, that's what I said.
Or does it measure dynamic and static pressure? All right.
Dynamic, right?
Stick your hand up if you think it measures airspeed. Stick your hand up if you think it measures dynamic pressure.
Sort of.
Stick your hand up if you think it measures static pressure. Stick your hand up if you think it measures dynamic and static pressure.
Yeah.
Yes, unfortunately, you've got both going down there. What we want is the dynamic pressure, but the pitot tube itself doesn't separate the two, because dynamic pressure is the pressure that's created if you're moving forwards, for instance, and the static is just around us already. Well, if I move my hand, I can feel dynamic pressure, but unfortunately, there's also some static pressure there. If you wanted true dynamic, you've got to get rid of the static. So how the heck does it do that?
There is
the pressure inside the helicopter where it hasn't got any air movement.
Not bad. Close.
There will be some sort of chamber though somewhere. So,
Yeah, you kind of, it's not bad. It's pretty good. Your brain's working.
Vacuum somewhere.
Well, we don't want to vacuum, but all we've got to do is separate the static from the dynamic. And all you got to do is inside the airspeed indicator, you just want a way of separating them. So the pitot tube basically goes to the airspeed indicator. But remember, that's got both. But what you want to do is get a shot of the static pressure out of it, and it just has a vent really to a static. So you can subtract it, and all you're left with is the dynamic pressure. Now we can make the needle move, and hopefully, roughly speaking, point to the right airspeed. So does the airspeed indicator measure airspeed?
no, that's the difference of pressure.
This is dynamic air pressure.
It measures the difference, but the reading is.
But it gives you that. The gauge is set up to give you that reading.
Yeah, good. So therefore, if it says you're doing 90 knots, are you doing 90 knots?
Through the airspeed.
And even that's not accurate, is it? Because it depends. So take today, it's a bit of a high pressure day, so they all overread. Because it's unfortunately it's not permanently recalibrated.
Yeah, gaining its static air pressure from inside the helicopter where air pressure is changing.
There could be that as well, but it's just simply because the air is a bit more dense today down the heights we're flying at. There's a bit more dynamic pressure going down there, so they just tend to overread a little bit. That's all. Not significant, but it was just the way I worded it. It's that classic, if you're not careful, exam question. You might find actually it doesn't just measure airspeed, it might be true airspeed or indicated airspeed or calibrated airspeed or rectified airspeed. So there's a few you need to kind of get your head around, but the general gist is the airspeed indicator might not truly be telling you exactly how fast you're going. It's a pretty good idea, but it might not be exact, so be careful. It's like the speed of in a car, unless it's a very modern vehicle coupled with GPS, it probably isn't telling you the truth, and then you normally overread slightly, especially if your tires are worn.
Definitely overread.
Yeah.
But what would be the range in which?
Oh gosh, it can be significant if you fly altitude.
Okay.
You fly up at say 20,000 feet. The air's a lot thinner up there. It massively underreads quite significantly. And the problem is then you think you're going slow, so you try and fly faster, and that's not a good idea. So there are charts normally with the aircraft. You can look at what altitude or what the density of the air will be up there, and even on our whiz wheel computers, and recalculate it. So we understand if you want to truly fly at this speed, you actually need to have it indicating this speed. There's a difference between them because it might affect your timings. Over the distances we fly, it's minimal, but you do a transatlantic crossing, it's quite significant then, the time difference of what you think you're flying truly to what you're flying. Anyway, that's navigation. Okay, so airspeed indicator, yep, really kind of does kind of measure dynamic pressure, doesn't it? At the end of the day, it gets rid of the static and turns it into something, vaguely speaking, indicated airspeed. So how does an altimeter work? Yeah, it's measuring. It's
But with, I think it depends on where you're flying. Because if, and depending on the height, the altimeter can at times
High pressure down here, isn't it?
Yeah.
so, oh yeah, good.
Yeah.
Generally speaking, yes, the pressure down here is less than if you go up.
So it
Any
might-
idea roughly how much that pressure changes as we go up?
1 hectopascal
Yeah.
every 30 feet. Yeah, I think that's 1 extra 30 feet.
But that's only on a kind of standard day.
Yeah.
That's it. You got it. International standard atmosphere, and of course, it's not always like that. Which means, therefore, the altimeter probably is not actually.
Probably a lot of money there. I've got a paperweight on my desk now, one of them.
So I've just gone and got an
Yeah, I needed another one.
altimeter out of my
Don't throw that
office.
away.
So another classic one. Does the altimeter measure height? Does it measure altitude? So what does it measure then? I thought, it tells us how high we are.
Pressure.
Really, it's just measuring the pressure, isn't it? So therefore, it's just really a barometer, isn't it? Is that right? Yeah, it is. So here's one I decided to pull apart. Oh, you can't see this online. I'm just taking one of them apart. Inside the altimeter, you've got these little capsules, and they're kind of like little brass copper bellows. So these are sealed up with some air trapped in there, which I don't know for a certain, but I would assume it's at 13.2 hectopascals. That would make sense. That's the pressure inside those. So even if I do that with it, the pressure up there compared to where it was just now is it's a fraction, but those bellows would have just expanded slightly, ever so slightly, which via a bit of very, very sensitive mechanism makes the needle move around on the altimeter. And if I bring it back down, it probably compresses them slightly and makes the needle move. The problem is it's all every day it's different, isn't it? The pressure and the gradient of how much it changes. So therefore we need to be able to kind of calibrate it, adjust it, don't we? So I could just put this one, for instance, by twiddling the knob round onto 0, and I probably can't do it enough in this room, but if I move it, that needle will just move a smidgen. Or if I very carefully, all I did was just suck very gently on the back there, just to create a slight drop in pressure on that one little point, which made those bellows expand because I reduced the pressure inside the casing. So these all have to be sealed up. That's why it's things like a rubber seal on it. So that's all sealed up completely, as it were. Or so it can't be, it can't leak through it because you don't want the pressure equalizing in there. Therefore, it only has one supply of what sort of pressure? Static, yeah. So it just has to have a static source. It doesn't need dynamic or anything like that. And then we just have to alter this knob to put it to whatever we want setting wise, whether it be at the airfield, for instance, on the kind of highest point of the runway for 0, or whether it be above sea level. So today, it's probably dropped a bit now. That's about right still. You won't necessarily see it, but on the little subscale, I've put 1030. It was actually 1032 earlier today. And that's showing a reading at the moment of about 275 feet above something. Above, which means sea level. Give or take a bit, because it might not be that accurate today.
So recently, Paul, given that the subscale is such an important part of flying, why on earth did they not put in the glass that covers the altimeter? Why did they not put a slight bit of magnification on the subscale? Because the only reason I wear glasses when I fly is that's the only bit that I need glasses for. And I actually started to look on Google. I started to look online for. You get these little stick-on.
That's right. Jet Ranger's got one.
Yeah.
Because the previous owner obviously didn't have very good eyesight. So Clay's got.
But it occurred to me,
a little magnifier
why
on
did they
that subscale.
build in magnification into the lens on the subscale?
Ah, because all us pilots have got 20/20 vision.
Yeah, it's such an
Yeah.
important.
You're right.
It's one of the most important things, isn't it?
And that's always the one you.
And
do
it would
struggle.
solve the problem for so many people.
Potentially, yeah.
So that's what I'm going to do.
Or potentially, if you know already, for instance, this is not exactly how we should do it, but if we were doing circuits today and you're in your helicopter, you would pretty much put it on 0. If you knew the elevation of the airfield, well, it's 332 feet, but it's up that end of the runway. We're a bit lower than that by probably about 50 foot. So 332 minus 50, well, hey, I get to somewhere about 270. And funny enough, it's on the right settings.
So the Jet Ranger, is that how it come, or someone stuck that?
Somebody stuck it on there.
And it works, does it?
Oh yeah. It does for the pilot, it doesn't for me. It's damn awkward because I have to look across the cockpit. I literally can't see it because it's magnified in such a way I can't see it. So I have to kind of almost lean right over. Oh, I think they got it on the right setting, but I just have to look at what the altimeter is saying height-wise or altitude and figure out if it's about right or not, if they got it on the right setting. Yeah. Okay, so altimeter, really just a barometer, isn't it? With the scale on there that kind of equates to sort of hundreds and then thousands of feet. A little knob that we can alter depending on what the pressure is right now. We call it the Q&H pressure, the sea level pressure. So how does a vertical speed indicator work?
Works on static source again.
Yep.
And it's got some bellows with a small hole in it, so it kind of like lets air escape at a certain speed.
Oh, that's interesting. Just say that again. To the bellows, air escapes out of them.
Yeah.
Yes, it does. So there's a tiny, I haven't got one, but there's a tiny little hole in the bellows. Tiny little hole, very precise size for the instrument. So it leaks. So the idea is a vertical speed indicator is actually not that dissimilar to an altimeter. It almost looks the same inside. So that as it changes height at a rate, the little hole leaks very slowly. So it will allow the bellows to equalize, but during this process, it makes the needle move. In this case, it points upwards and maybe at how many hundreds of feet per minute we're going up. But if I stop, it leaks, it equalizes, the bellows return back to their normal size and the needle goes down to 0. Come down, the reverse is true. There's a bit more pressure trapped inside the bellows, so they expand and makes the needle move, in this case pointing downwards. But as we stop descending, it leaks and zeros again. That's why there's a bit of lag on that needle in the vertical speed indicator. Potentially somewhere 3 to 5 seconds it can be behind, depending on just how quick you're going up and down. There are more modern ones. You can have instant reading ones, but good old classic, just via static pressure ones will just, they'll have a bit of a delay inside them. But yeah, the vertical speed indicator actually is very, very similar to an altimeter. There is even, it doesn't work quite the same, there's even a little knob to kind of adjust the needle for 0, etc., and all these sorts of things.
So with all these new aircraft with glass cockpits, you don't have traditional instruments, do you?
Well, potentially no. Some still have some analog instruments.
If you've got glass cockpit and it all goes.
Well, you kind of have backup systems for that.
There are backup.
Yeah, there's sort of
So
electrical backup systems, but it is
they've got redundancy. So
it is still theoretically possible. So we did have. I think the last time I heard of this being a problem is it's an SR-22 aeroplane with a full glass cockpit. The poor pilot, his radio was working, but nothing else was working. You could hear there's a little bit of stress in his voice because he couldn't see anything about the aircraft, how fast it was flying, how high, other than looking out the window. RPM, nothing. The whole lot just failed on him, the entire glass cockpit. Yes, he was a little bit stressed about it, but
what a fire in a glass cockpit, sorry.
Glass cockpit's like your modern
like laptop.
Why expect the instruments instead of
No, because they do away with all of that.
Yeah, the instruments are just stuck on a straight line.
All on the CRT screen.
Yeah, you know, it's like you see, I don't know, spirit level on your phone. Fantastic. Yeah, right until the phone does that to you. It's like, oops, that's gone. So yeah, there's definitely some pluses behind having good old analog instruments and gauges. I mean, take some of the really old tech. I talked to let's say James has done the Jet Ranger type rating, and saying to Lee and Derby in the beginning, you know, it's actually really old technology, but a lot of this is good because what it means is all the electrics can fail and the thing just carries on flying. During daylight, you have literally got no worries. Half of the instruments will still work, or actually most of them will still work. Even a load of the gauges, the RPMs are all come off of these little thing called tacho generators that generate their own electricity, that transmit onto it for RPMs of rotors, of engine speeds, of turbine speeds. The things like the oil pressure and temperature, they're wet lines, so they go direct to the engine. There's no electronics involved in them. So literally, to a degree, you have an electrical failure. At first glance, you wouldn't even know it's happened until you, hang on, there's a couple of things aren't working here. It's pretty good.
On screen, is it in the middle? Okay, isn't it?
But it's
Everything.
it's old tech, you know. Whereas modern is very nice, but and for the most part, it's very reliable. Of course it is, but it's still possible. But there are normally, say, redundancy systems. So, for instance, not all the screens will all be linked to the same power supply. The screens will have doubled up, so you wouldn't just have one attitude indicator; you'd have multiple attitude indicators. You might even still have an old analog one or a gyroscopic one. This sort of thing. So if one screen fails, it's fine. You've still got all the others. You know, it'd be almost impossible to have a complete, utterly electrical failure. You'll have backup batteries, no doubt, all these sorts of things to ensure that just really can't happen. Yeah.
Can I just tell you about next month?
Of course you can, sweetheart. What are we doing?
27. It's an extra week, I'm afraid, because we're having Amanda come in.
Oh yes, that's right. Yeah,
in person for our tea.
It's funny enough, I talked about it because I was talking to her on the way home last night. She's messaged me. She's very much looking forward to coming. She's coming in person, I think, isn't she?
Yeah.
Yay, that's it. So that'll be good. But that's on the 22nd of October, isn't it?
Right. I'll see you later.
See you later.
Bye.
Well,
Bye.
yeah,
Bye, Sue.
There'll be radio telephony. So we're very lucky to have some very good friends. I think I was talking about them earlier. Amanda's going to join us, which is great because we quite often talk to her colleagues at Luton, but they're not really at Luton, they're down on the south coast.
On screen before?
Yes, she's been online with us many times. She's been in here as
Yep. Came in once a couple of years ago.
and it's really good, especially if you're learning to fly, because it takes away that stigma of talking on the radio. Believe it or not, for a lot of people, it's a really big thing to be able to squeeze the trigger and speak.
I'm fine with it.
Brilliant, excellent. But it's nice to hear.
I need to go as well. So
Sometimes, all right, Sophie.
Bye, Sophie.
When
bye, everybody.
Bye. Sometimes when we hear a air traffic controller, it's it sounds really serious and oh my gosh. And actually, when you meet them in person, they're just normal people. So Amanda's very good at coming across like that and giving.
I understand what they're saying half the time.
Yeah, that's right. It's half the battle. That's it. What are they saying? What do you need to say? What are they saying to you? Well, anyway, there's a bit of aircraft general knowledge. I hope some of that's helped. No matter what sort of skill level you're at. Like I said, there's obviously lots more to learn, but it's just a part of it, isn't it? It helps encourage you in that subject. It's not as bad as it seems. And the reason why sometimes it's really nice to know maybe what's inside an altimeter, because then you get a bit of an understanding if it's not working properly. You can understand maybe why it's not working, or is it giving you a false reading? Don't just truly believe it. Just something simple like that, isn't there? Carburetors, we were talking about that earlier. Why would you want to understand the Bernoulli theorem? Because it causes a drop in temperature, which causes icing, which is actually really bad because it causes the engine to stop. So therefore, we keep an eye on that, and we understand, and we have systems to stop it. Thank you for joining us. Good to see you, James. Thanks for joining, matey. Hope the salmon was all right.
Oh, it's delicious. No, I miss doing these things, so I'll try and attend as many as possible.
Yeah, it's good, and it's
Good seeing you.
Yeah, we know
You too, buddy.
as instructors, when we're teaching this stuff, it's good to go back over. You suddenly realise all the things you've forgotten or don't know, and somebody asks you an awkward question, and rather than bluff it, you sort of have you go and find out, and it just improves your knowledge, doesn't it?
Yeah, I mean, it's all gone now.
You get out of it. Yeah, it's lovely. Well, look, take care, everybody.
All right, thank you so much.
Either see you
Thank you so much.
in person or online on the 22nd of October. I'll do the usual. Catherine will send out all the MailChimp whatnot, and I'll do the invites so we can see you either online or in person. But yeah, Amanda will be here, which is really nice. She's lovely, and we'll talk about as much as she can about air traffic control at Luton and various places and things she's seen and done, and reassures us actually we do a half decent job on the radio, our end, and what she needs from us when we talk on the radio. Yeah, good show. See you later.
Thanks very much. Thank you. I've finally got that sound working.
Hey, that's good. Yay, so you did. And we can see you. Look at that.
Thank
And
you.
and you're not that far away, so do come and join us next time if you want to in person. I say it's really good with Amanda here. Really
Yeah,
good.
thank you.
No problem. Take care.
Right, thanks. Bye then. Bye.